Okay, so let's take a look at the next example. You'll see that we have one term on the left-hand side and one term on the right-hand side of the equation. And you'll also notice that there's no easy way for me to change 3.92 to a base of 5. So what I'll do instead is take the logarithm of both sides. And what we can do from now is actually bring down the exponent part, which is where the variable is that I'm trying to solve for. And so I'll bring down the t minus 1 using the power law of logarithms. And there's a couple of different ways of working out the question from here. So since there's only one variable, as opposed to the previous question where you had a variable in two different places, in this case, because I have a variable in only one place, what I could do is divide both sides by the log of 5 and then remove the 1. Or I can expand, rearrange, and then divide from there. Okay? The first method is a little bit easier than the second one that I just mentioned. So what I'm going to do first is eliminate the log 5 by dividing both sides by the log of 5. And so what I'll be left with is t minus 1 equals the log of 3.92 divided by the log of 5. And what you'll notice now is to eliminate the 1 from the left-hand side, I just need to add 1 to both sides. And I get t equals the log of 3.92 over the log of 5 plus a 1 on the side. Okay? So this is the solution for part B. Okay? And again, if I expanded and simplified and rearranged differently, you would have had a slightly different answer, but the value of the answer would have been the same as the value of this answer as well. Okay, we have a couple more examples here for question number 2. And again, we're leaving answers in exact form. So if I look at this, again, I have one term on the left-hand side and one term on the right-hand side. And I know that there's no easy way for me to write 8 with a base of 3. And so instead what I'll do is take the logarithm of both sides. And again, I'll apply the power law to bring down the exponent part. So I get x plus 1 in brackets, again, because it's more than one term, times the logarithm of 8 equals x minus 1 times the logarithm of 3. Now in this case, unlike a previous example I looked at, because there's a variable in more than one place, I actually need to do the distributive property first so that I can get the x term combined with the logarithm term. Then I can get the x terms on one side and then try to isolate the variable from there. So unfortunately, I do need to do the distributive property in this case. So if I apply the distributive property, I get x times the log of 8 plus the log of 8 equals x times the log of 3 minus the log of 3. And I want to try to get the variable terms on one side, so these two are our variable terms, and the number terms on the other side, so those two are our number terms. So I'm going to rearrange the equation slightly, and what I'll do is actually move this term to the left-hand side and bring the variable term to the right-hand side. And the only reason why I'm doing that is so that I can try to keep both sides of my equation with positive terms where possible. So on the left-hand side, I would have log of 8 plus the log of 3 equals, on the right-hand side, I haven't moved x log of 3, so that stays there. And I'm going to subtract x times the log of 8. And now you'll notice that our variable terms on the right-hand side, and I can factor out the coefficient here on the right-hand side. So I have a common factor of x, and I'm left with log of 3 minus the log of 8. So all I did on the right-hand side is factor out an x. And now to get x all by itself, I can divide both sides by the log of 3 minus log of 8. And I'll do that to both sides. And so I'm left with x equals the log of 8 plus the log of 3, divided by the log of 3 minus the log of 8. And there is our value for x. Okay? And so you'll notice that I haven't canceled anything out because I cannot cancel anything out. Okay, I can't cancel the log of 8s and the log of 3s because there's addition in the numerator and subtraction in the denominator, and those operations have to happen first before I do any sort of division.